here. Again, in case you missed it on the part one, if you want to fast forward through the video, I put in the description just times that I'm working on different problems, or you can just kind of funnel through and I mark when I start a problem. So we're going to go over in this video just 7 through 12 as we work through this. All right, so let's start going here. So 7, so budget rental cars, cheap rentals, has nothing but budget cars for rental. All right. Good advertisement, I guess. The probability that a car has air conditioning is 0.5. So I'm just going to start writing out what I got here. Okay, so we got AC is 0.5. The probability the car has a CD player. Oh man, this is definitely telling the date on this book. All right, 0.37. The probability that a car has both a air conditioning and a CD player is 0.06. So AC and CD player is 0.06. All right, or 0.06. Yep. Okay, so instead of getting like this is more of a remember, it's not the classical probability, right? It's so it's looking at an experience. So if we look at this here, what is the probability that a randomly selected car has neither air conditioning nor a CD player? Okay, so we have to consider the fact that, well, let's find the probability it has nothing, right? So we have to consider the fact that we have, if it has AC, and I'm going to use the complement in this case. So I'm going to say AC is 0.5, all right? It could also have the CD player, which would be 0.37, and kind of this is kind of a baiting you into thinking, it's kind of walking you through the idea of an inclusive situation, right? Because it's saying, what is the probability the randomly selected car has neither air conditioning nor a CD player? Well, I'm finding again the probability of having a CD player, and then I'm going to subtract that overlap because I don't want to count it in either one of those, okay? I'll write that a little bit better. Hopefully I'm doing an okay job explaining this. So subtract the overlap where we have those cars that have both of them because they are being counted in here. And the way I know that, and maybe you can kind of see what we got going on here. Let's see, minus 0.06. All right. So we have AC, CD, and then assuming that those are also being counted within that one as well. So if we go across here, we add it all up, we get 0.81. So that's the probability that it has AC and a CD player. And again, we subtracted the overlap. So that's 0.81. So to find out that it has neither, I would take 1 minus 0.81, which would create 0.19 probability. Okay? If by chance you chose 0.07, that's because you included this AC and CD were counted within this. So that's why I'd recommend maybe going the complement route to this. All right? All right, let's dive in. 8. Okay, so I got my chart here to help you out. Now on the test, you're also going to get one of these charts as a resource. So you don't have to worry about creating one. I mean, pretty self-explanatory there. So the sum of 5 or 6. So I got how many ways can I make sum of 5? That's 4. And again, we got 36 options here. For some reason I'm drawing 9s. So we got 4 out of 36. And let's see, 1, 2, 3, 4, 5. 5 out of 36. So we could, using the right vocabulary, a sum of 5, which is here, or a sum of 6. I'm just counting how many 6s I can make. And so that would be 9 out of 36, or that is a 1 in 4 chance. All right, so that's part A. Part B is sum greater than 9. So that would be everything in this corner right here. So 1, 2, 3, 4, 5, 6. 6 possibilities there, so 6 out of 36, which would be 1/6. C, a sum less than 4 or greater than 9. So less than 4 would be these 3 right here. So it would be less than 4. And then I also have greater than 9. So that would be these 6 right in this area here. So I have plus 6 out of 36, which would be 9 out of 36. Now make sure I'm not, there's no overlap going on here. So I'm okay in that area. So we got 1/4. Next up is D. D would be a sum that is divisible by 4. Ooh, nice. So let's see, that would be the 8s. Well, we've got to consider the 4, so we got 3 of those. We got 3 out of 36 because 4 is divisible by 4. And then we have 8. 1, 2, 3, 4, 5. 5 possibilities there. 5 out of 36. And then we also have 12, which would be 1 out of 36. So that would make it a total of 9 out of 36, which would be 1/4 again. We got a lot of 1/4 going on here. All right, so E, a sum of 14. Well, gosh darn it, there's no 14s on here. So the probability of that event occurring would be 0. All right. And then for F, kind of just testing your knowledge of just probability. Let's see, the sum is less than 13. Well, that would include everybody. And when we include the whole sample set or sample space, it would be 1 is our probability, or 1. I mean, if you're looking at percents, 100%. Okay. All right. Let's keep this ball rolling. I definitely got a bigger eraser now than I did in the last video. All right. Let's keep this train rolling right along. Next one up is 9. 9. Okay. So we have there is a 39% chance that John will purchase a new car. All right. So we got new car. 0.39, and then is a 0.73 probability that Mary will purchase a new car. So I should probably then label it like this: John, JNC new car, and then we got Mary new car, and that is a 73% chance of that occurring. Okay, so if you can read my writing there. And then a 36.36 probability that both will purchase a new car. Both. Okay. Now, judging by if you saw my problem number 7, you're kind of probably seeing a similar setup here. So both purchase a car would be 0.36. Okay, so probability both purchase a car. Find the probability that neither will purchase a car. Okay. So we have to consider this is an inclusive event. So this 0.36 is kind of mixed in with this. And I can see that by, do you guys see if I added these up, 0.37 and 0.39, they would be over 1, which tells me that there's some, we're including some of this both will purchase. The probability of both purchase a car is 0.36 in the out event. So we have the probability of, in this case, John, right? Sorry, where are we at on this? This is number 9. Probability that, hold on. Darn it, I think I'm doing number 10. I apologize. I'll come back to 9. Okay. Okay, so that's a 0.39 plus 0.73, and then I'm going to subtract that overlap, because this is, both is being included within that, and so that gives us an answer of 0.76. But again, it's asking for neither. So this is the probability that they would purchase a new car. And so I have to take that 1 minus 0.76 to find the answer, which would be 0.24. All right. So this is all going to mess up my descriptor now. All right, so number 9 here. Okay, so probability that a person owns a car is 0.8. Probably why I got mixed up. Car is 0.8, own. All right, the person that a person owns a boat is 0.3, so boat 0.3. And right away I'm like, okay, that's 1.1. So that means that they're probably counting the other part of this, which is the odds of the person both a car and a boat is, and I'm going to put this as both, is 0.1 or 0.12. Okay, so if we look at this one here, so find the probability that that a person owns either a boat or a car. So unlike the previous ones like number 7 and number 10 we just did, it's just asking what's the probability that they own either of these. All right, so we got that they can own a car. Whoop, sorry, got a leaky pen here. Hold on, let me get all fixed up. We got 0.8, so they own a car. I got the idea that they own a boat, but I do want to subtract the idea of the people who own both because it's covered in both circumstances. So 0.12. So the probability with this group of people, man, there's a lot of people that own boats around here. Or not boats, I guess a car too. So the probability that they own, probably the person owns either a boat or car is 0.98. So very high probability that they own either of those. All right, let's try number 11 now. Number 11, since we got all mixed up in our numbers, which is awesome. All right. Okay, so number 11, roughly 1 in 6 students enrolled in higher education took at least one online course last fall. Choose 5 enrolled students at random. So we know that 1/6 took enrolled in higher education took at least one online. Took at least. Now I know we've talked a lot about this phrase "at least," but in this case, it's just saying took at least one online class. If they were to ask us, like, what's the probability it took 2? We don't know. Like, we just know that 1/6 took at least one online class. So I'm just going to put that there and then not necessarily use the at least as the way it's been emphasized in some of these other ways, right? Took at least one online course. All right, so let's start breaking down this idea. So all took 5. So I'm choosing 5 enrolled students at random. So that's also where we're kind of looking at here. So we got, what is the probability that all took an online course? Well, think about this. That would mean that this first person, there's a 6 chance that they took an online course. The second person took an online course. There's a 1/6 chance that a third person, and then the fourth person, and then the fifth person. So really you're looking at 1/6 to the 5th power to determine the probability of selecting, and that would be pretty slim. That would be a 0.0001 or 1 out of 7776. Okay, probability of occurring. All right, so pretty small in that case. Okay, so again, we're using the and because this person, there's a 1 in 6 chance that this person took an online course and this person took an online, and so like using that and idea. None of the 5 took an online course. Now, the cool thing, you kind of look at this same logic. Well, what's the probability that I choose a person who did not take an online course? Well, that's a 5 in 6 chance. And what's the probability of the next person not taking an online course? Well, that's 5 in 6. So on and so forth. So we got this probability seems to be a little bit higher, but still, I mean, you could probably snag at least one of these people that is took an online course. And so that would be I'm looking at my notes here, 0.402 opportunity. It's a little bit higher. It's about midway through there. That you would choose a group of 5 that have no online courses. And then finally, similar to a problem that we had in our assignment, at least 1 took an online course. So I want you to consider this idea is that these at least, this is actually where my ears go up a little bit, and I know that, okay, I could kind of cheat the system a little bit. So if I'm saying I want to find the probability at least 1 took an online course, I could go through that process and do look at 1 and then the situation, or 2 or 3 or 4, or I could do that. Or I could look at this problem B and say, well, this is a probability that none took an online course. So can I just take 1 minus this to find the probability of all the other parts? Because it's saying all of them have to equal 1. So again, if I took 1 minus, I'm choosing 1 because all probabilities add up to 1 within the sample space. So if I just took 1 minus the probability of none took it, that covers all these situations, which would add up to 0.598. All right. Okay, moving right along here. 12, last but not least, we got number 12. Let's see. Kind of similar situation to what we just did of American using library services, 67% borrow books. If 5 patrons are chosen at random, find the probability that all borrowed books. I'm going to use this same kind of thing up here, or more notation over here, which is the idea that I can just take 0.67 to the 5th power, which would be 0.1350. So I could do that. And then that none borrowed books, okay? Kind of similar idea. I'm going to find the complement of 0.67, which would be 0.33, and I'll take that to the 5th power. And this is the probability that none had books, which would be a little bit smaller probability out of 5 people that none borrow books. And so that would be the answer there. All right, long video here, so just please, I encourage you to scroll through. I know, sorry about the 9 and 10, but we'll keep this train rolling here. Thank you.